arithmetic progressions in square numbers. I emailed him back about arithmetic progressions in calculating primes. And I had discovered some probable primes with 10,000 or more digits with arithmetic progressions, and he invited me to speak. First, I'll have some videos.
This is the biggest reason of all time. Every other number's composite. Can it be the truth? Oh, really bullshit. Don't you know we'll never find the biggest crime? 'Cause there's always more. There's no biggest crime. No searching for the biggest crime. That's the big crime. Whoa. That's a big crime. Whoa. That's a big crime. But don't get cocky. If you found the biggest, it's only proof. Oh, 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 you can't find the biggest. I'll show you the proof. Oh, oh, oh. If we found all the primes, then they're finite. Let's multiply them all, then we might add one to this number, and then 8 is indivisible by your prime. Wait, if nothing can divide this number but itself and 1, then we contact the prime, and our proof is done. Don't you know we'll never find the biggest crime? 'Cause there's always more. There's no biggest crime. No searching for the biggest crime. That's the biggest crime. Whoa. That's a big crime. Whoa. That's a big crime. But don't. That's a big crime. But don't. That's a big crime. But don't get cocky. Keep on searching, guys.
This is the largest
I say math and you say D minus, don't worry. This is just a primer on a prime number bigger than anyone's ever seen. You could call it the Optimus prime number, the prime minister of integers, the dominator of denominators. That might not be right, but it sounded cool. Point is, this is the ultimate integer so far that's evenly divisible just by itself in the number 1. So you can count on it being a little bigger than 3, 5, 7, or 11. Factor in the fact that it took a computer to find it and then a reported 39 days to prove it's indeed a prime, and you can't subtract a thing from this accomplishment. So what is it? I can't tell you, and it's not just because I didn't ace math. It's because it's more than 17 million digits long. We can tell you that it's 2 to the power of 57,885,161 minus 1. That doesn't make it any clearer. What is clearer to mathematicians is that this isn't the biggest prime out there. Euclid said back around 300 BC that there are an infinite number of primes. Will number crunchers continue their quest to find them? Euclid bet on that.
The 17 million digits divided by 3,486 digits per page is almost 5,000 pages. Printed on both sides of the paper, it would be almost 2,500 pages, or 5/6 of this box of computer printer paper. And here's the second largest known prime.
We all learn prime numbers in school. They're numbers that are divisible by only two whole positive numbers themselves and 1. The smallest are 2, 3, 5, 7, and 11. Mathematicians at UCLA announced that they have discovered the largest known prime number. How big is it? Nearly 13 million digits long. Let's put it this way. If you wrote out each digit so that they were a foot wide, and then laid out all the digits end to end, they would stretch from New York City to Phoenix, Arizona. There's no way we can show you the entire number, but here's how it starts. And it just keeps on going. All 12,978,189 digits. UCLA researchers used a network of 75 computers to find what is the 46th known Mersenne prime. Thousands of people around the world have been participating in a worldwide competition where underused computing power is harnessed to perform the calculations needed to find and verify Mersenne primes. There's a $100,000 prize for discovering the first Mersenne prime over 10 million digits. Now the race is on to find the first with over 100 million digits. Matt Friedman, The Associated Press.
And it's estimated that the number of subatomic particles in the universe is 10 to the 80th power, so it would be more than the subatomic particles in the universe. Almost 13 million digits divided by the number of digits per page would be more than 3,700 pages. Printed on both sides of the paper, it would be more than 1,800 pages, or 5/8 of a box of printer paper. These use GIMPs, the Great Internet Mersenne Prime Search. In case you were wondering from the previous video, first 100 million digit base 2 number would be this, but it's not very likely to be prime. And that one would be 4 4/5 boxes of printer paper. Mersenne primes are 2 to the power of a prime number minus 1. I'll talk about the origins of primes. The Ashango bones of baboons discovered in 1960 in Belgian Congo from about 20,000 BC, or the Lobambo bones of Swaziland in 3,500 BC.
25,000.
What?
25,000.
And if somebody thinks I'm going too fast, you can just tell me to move back a slide, or you can ask about something. Let's take a closer look at the Ashango bones. They have odd numbers. There are different theories about what they mean, and there's a debate. One theory is that they use Egyptian math, base 60 math, that they're cycles of the moon, or women keeping track of their periods. The Sumerian cuneiform in ancient Iraq had a list of primes, according to Vern Foley, one of my history professors. They were base 60. So it would be 2, 3, 5, 7, 11, and so on. One theory about why the Sumerians used base 60 was that they had problems with fractions, or that there were 360 degrees in a circle, or about 360 days in a year. Let's talk about Titanics, numbers with 1,000 or more digits. Archimedes was famous for figuring out how much of a king's crown was gold. He's famous for the Archimedes spiral, among other things. His myriad of myriads is 100,000 to the 100,000th power, 100 million to the 100 millionth power, or 1 followed by 800 million zeros. It obviously isn't prime since it ends with 0. He believed in the sun god or sun titan Hyperion, and had a riddle about how many cattle were needed to pull the sun across the sky. It was almost 6 trillion, or a multiple of a 206,000 digit number. 206,000 digit number Well, before you jump to the conclusion that he was on mushrooms, it may have been propaganda against Archimedes because there was a war, or they wanted his land, or they thought that he was a threat to the Roman Empire. The mathematics teacher newsletter in 1971 published a 1,560-digit number, a bracelet number, but it wasn't prime. The same publication mentioned one with 1,000 zeros in 1973. Samuel Yates defined titanic primes as 1,000 or more digits. Gigantic primes are 10,000 or more digits. Yates died and Chris Caldwell took over the Top 5,000 database in Tennessee. It's a database where you don't need a password. It's open to the public. And let's just click on search. Click on all. Let's find all the primes with 1 million or more digits. And there are 63. Somebody this month just discovered one with 1 million digits. And these are the primes from the YouTube videos. And there are also believed to be 10 to the 2,400,000,000 DNA combinations in Life Science Library Mathematics in 1972. It's interesting to read math books from before the internet. I thought it was 4 to the 6 billion power in humans because there are 4 combinations of base pairs. There are 6 billion of them. I was in the 99th percentile in math, heard about the number Google from elementary school, and a math show called Square One interested me. Disney's Chip and Dale Rescue Rangers had a joke. The gazillionaire's wife had so much money that she spent 3 weeks writing zeros on the check. I was in 3rd grade and I thought that that's the stupidest thing they said on the show all year. Because if she wrote down a 0, 1 second, 60 seconds times 60 minutes times 24 times 7 times 3, that would be more than 1 million. And 1 million would have 6 zeros, not 1,000,000 zeros. Also, I was in math counts. In 2003 or 2004, reading the Purdue Exponent, I saw 2 computer articles that caught my eye. A leukemia cure crowdsourcing screensaver that's probably a precursor to folded beta. They take different proteins and they compute how they unfold in water or enzymes, and I just wasn't familiar with the chemistry of radiation or chemotherapy, so I didn't stick with it. But about the same time in the Purdue Exponent, Purdue students tried to find an equation to find a prime with over 40,000 digits, and it didn't work. I don't have that article anymore. I'm not sure if their names were Chen and Wang, because in the little book of bigger primes, Chen and Wang tried to find an equation with over 40,000 digits, and it did work. Also, there's a 2005 Discover Magazine article about arithmetic progressions in primes. You start with 199. You keep on adding 210. It's a 10-term arithmetic progression to find prime numbers. Okay, and at the time, the largest known number of primes in arithmetic progressions was 22. You start with 11 trillion and go up in steps of 4 trillion. And then there's another one. Start with 376 trillion go up in steps of 18 trillion. I already showed you the top 5,000 primes webpage. About the year that I had read the Discover magazine article, the 5,000th place prime had 70,000 digits. Now the new prime in 5,000th place has 280,000 digits. There's also the top 20s complete index with different themes of primes. These are just the ones they care to list. And they got really creative with the prime curios. There's also the Lifshitz brothers probable primes with 10,000 or more digits. I'm now on here. I email Giovanni and Maxim from the Rep Unit Project, who are also on here. I know of Makoto Kamada, who worked with Rep Units. I'll explain the Rep Unit Project in a little bit. Why are primes important? There's public key cryptography. You have prime 1 times prime 2 and it equals a composite. The composite is a public key. With P1 and P2, they are private keys. You can't guess the prime number for a private key because it would take over 1,000 years. And primes are also important for education hypotheses. Autistic savants like Daniel Tammet, Yuan spiral. This is a Yuan spiral. It starts at 2, 3, 5, 7, and there's a dot at every prime number. Theorems, formulas, the search for extraterrestrial intelligence. You might like the movie Contact. They intercept primes from space. And primes don't just happen in nature. If you receive a signal, that's just all the primes in order. It has to come from Earth or aliens, and that's the premise of the movie Contact. Mersenne primes, bees and rabbit tree families, bee and rabbit family trees with Fibonacci numbers, contests, prizes, and etc. With Mersenne family trees, you have 16 second-degree great-grandparents, plus 8 great-grandparents, plus 4 grandparents, plus 2 parents, plus yourself, and that's 31, a prime number. And you imagine that with 2 to the 57 millionth or 59 millionth, it goes back very far. Rabbits have a gestation of a month, give birth in our 1, 1, 2, 3, 5, 8, or 13 pairs in the previous month. This is the Fibonacci sequence. 1, 1, 2, 3, 5, 8, and 13. 13 is a Fibonacci number. With Pascal's triangle, you go diagonally, and it's a Fibonacci number. Bees must have something strange with their chromosomes. The male has 1 female parent. The female has 2 parents, 1 female and 1 male. So it goes 1, 1, 2, 3, 5, 8, 13, and so on. And the largest probable Fibonacci prime is over 400,000 digits, and discovered by one of the Lifshitz in France. And you'd have to email them if you want to discover a Lifshitz, a Fibonacci number. They have the program. And the sacred geometry or golden ratio or phi. 1.618033 is in a lot of things in nature, like nautilus shells. I'll put variable n or x in red in these slides, and if anybody has a question, then just interrupt and ask me. From Wolfram, the Euler formula is x squared plus x plus 41, and that's prime for x equals 0 to 39. And I've discussed the discover equation. 210 times n plus 199 for 0 equals, for n equals 0 to 9, and other discover equations. So the first time I discovered a prime that I care to remember, I was trying to figure out a 1,000 digit prime. So I took n in the equation n squared plus n plus 41, and I changed it to 10 to the 499. And it happened to be prime, but it was 999 digits, not 1,000, so I was a little bit upset. And now I'm just happy that the computers are working 5 times faster than the year that I discovered it. That might make you happy when you're trying to find a prime. So it was submitted to the Prime Curios page. I have these prime form equations. Prime form is a program that they don't use anymore. I had parentheses 10 to the power of n, parentheses squared. And I started at 0 digits, and as the n value went up, the x value went up higher and higher like it was on steroids, you just discover more and more primes with 10,000 or more digits. It took days to discover primes. Sometimes I would discover none in a night, sometimes I would discover 1 or 2. Here's another one, 20,731 primordial. Now that pound sign, that means that's primordial. It's all of the prime numbers multiplied together all the way up to that number. But I couldn't include 41 because it's over here. So I had parentheses n times 2 plus 1 in parentheses primordial divided by 41 in parentheses. And that's how that was calculated. I have base 2 formulas and base 10 formulas. You can just leave it running on your computer when you go to class or to work or to sleep. Other equations I've discovered, but these are different. These are with the equation, the formula x squared minus x plus 41. These were discovered with a newer program, OpenPFGW. And based on the equation, I divided it by 199 and 11. So I pumped up n on steroids again, and I add 199. These are the equations from Discover Magazine that are in the trillions. This is all online. Anybody have any questions so far? And here it's another number that's primordial. generalized Fermat numbers usually are k times an even base to the power of a power of 2 plus 1. Now, k can be equal to 1. So you have it to the power of 2, 4, 8, 16, 32, and so on. Somebody discovered one last year with an exponent of more than 500,000 and almost 3 million digits. I'm trying to find the top 5,000 generalized Fermat in UPGen. That's a sieve with over 410,000 digits. So I tried to alter the equation. Instead of an even number for n, what if you have an odd number? And then you multiply it by 4,096, and then you add 2. Works with 2,048. $1,024, 512, 256, and 128. Do you have a question?
Yeah. So, any particular reason why you chose these numbers?
Oh, the generalized Fermat numbers are the most common numbers on the top 5,000 lists. And if I noticed that they're that easy to discover, that I might as well take an odd number, multiply it by a power of 2, and then add 2. And the reason why those numbers are strange is because I just could quickly calculate which one would be the smallest 10,000 digit probable prime number. That does not have 100 digits. That does not have 100 characters. Henry and Renard will allow an equation with up to 100 characters on their website. And with the different themes, a palindrome is a number or phrase like Anna nav a banana, or a man, a plan, a canal, Panama. A man, a plan, a canal, Panama. Anna nav a banana. That reads the same forwards and backwards. And I'll have a demonstration of this. This is the most complicated equation I have up here, but I was just playing around, copying and pasting, and I had a palindrome that's 271 digits. And I worked out what the equation would be. And here's an n value where if you pump it up on steroids, if it gets changed to over 1,000, then you have a probable prime palindrome with over 23,000 digits. And this is kind of crazy. In the Commander King computer games and in homebrew computer games, people add in the dope fish as an Easter egg, just for the heck of it. And these are different digits for the border. It took me a day to copy and paste that, and it took me overnight for it to find the value that's added to this to make it a probable prime. Now it would be faster because you have OpenPFGW instead of prime form. If you think that you discover a near random prime or a picture prime or primes of over 100 characters, then since they're all over 100 characters, then you can have them linked to me off of. Let me demonstrate how. This is a goofy name for a website, Psychic Science, but they have a good random number generator. Generate 27,000 random integers between 0 and 9. open sequence, and then it calculates them. But it's going to take only about a minute to find a near random digit number. And what I mean by that is I took a number that I copied and pasted. Hold on, let me find Microsoft Word. Where do they move Microsoft Word in Windows 7?
In that word.
Start. Programs.
You can just type in Word.
Yeah.
Type in the word.
You can just select from the top.
Second.
Okay. So it should take a couple minutes. That's not the thing I cut and pasted. Okay, I'm trying to demonstrate. Wait. Okay, shouldn't be too hard to find.
Sorry, it's just the Yahoo thing. Sorry about that.
I don't believe in psychics, but they have a good random number generator. Something didn't get copied right. Okay, I didn't copy that right. And then you go into Microsoft Word, paste it. You go to replace 0 space and 0. Now it will remove all the spaces where there's a 0. Now you have it 1 space and 1, and it removes all the spaces that are behind a 1, and then you keep on doing that. So you take, this was from this morning. I was able to calculate a prime with over 3,000 digits. I made the same number of digits that would fit on a page in Microsoft Word. So if you want to find a near random digit number, type in, this would be 2 lines, but it's such a long equation that it's more. Type in ABC2 space 2 times $A plus, and then the random digit number. And then you have it A colon from 0 to whatever number you want. You save it as worktodo.txt. You open PFGW. Okay. You have the file name. Let's find a near random digit prime that took only about a minute. Okay, it actually found more than one. I did this morning and I only found one. That's how you find a random digit prime with over 3,000 digits. Okay, Alphatron is the one I already showed you. Alphatron.com.ar Argentina/ecm.htm. That's the one that you need Java to use. It works with Google Chrome, in Mozilla Firefox, but not always with Internet Explorer for some reason. And it's for finding smaller primes with about 9,000 digits or less. Okay. Another program I use, NewPgen. It uses the Sieve of Eratosthenes. You may have heard of Eratosthenes from Carl Sagan's Cosmos, but imagine that you can take 400 million equations. It eliminates millions of equations instantly, because it first eliminates the ones that are multiples of 2, then the ones that are multiples of 3, 5, 7, 11, and so on. This file is at 34 trillion. And so I typed in, a while ago, I typed in 2 for the minimum k value and 400 million 1 for the maximum k value. This was several days ago. Sometimes I save the file after a couple minutes, sometimes I save the file after a day. But where there's that k, it would be a number between 2 and 400 million. So at the very beginning, it would eliminate millions in a second. Several days ago, now it's eliminating 1 k value about every 5 seconds. So since I've gone to this room about an hour ago, it's eliminated more than 600 combinations. And then you run it through OpenPFGW. I read that more titanic or gigantic primes have been discovered with prop than any other program, but I don't use prop much. Prime form is no longer on the internet. Use OpenPFGW from me or the Yahoo group or a download PFGW internet search. GIMPs, the great internet mercenary, Prime Search, and Prime 95 are fast, but you need to know how to use them. Okay, the RepUnit project, it's an Italian website, but they know perfect English. It lists the RepUnits and elec with a K, electrosoft.it, and then you click on Mathematica, then you click on RepUnit. If you want to start, then you email Maxim or Giovanni. They are mathematicians, and I participate in this project too. Now, I use Windows XP and 2 CPUs. You can test 2 RepUnits with over 2 million digits in 2 or 3 days. It tests them both at the same time because you have 2 CPUs. Every digit in a RepUnit is 1, and the number of digits is prime. You don't have to learn very much more math or programming. It's very easy to do. RepUnit primes include 2 digits, 19 digits, 23 digits, 317, and 1023. Let's have a demo of that. If I just type in a random number, it's not going to be very likely to be prime. It's going to factor it. But I'll type in a RepUnit number, 10 to the 1031st power minus 1, and it becomes all 9s. And then you divide by 9, and then you get a number that's all 1s digits. and it's 1,031 digits. It's proving it prime and base 2, 3, 5, 7, and so on. The probable primes, because there's different criteria for Chris Caldwell's primes website, the top 5,000, that there is for the Lifshitz Brothers website. The Lifshitz Brothers website have 10,000 or more digits, and they use different equations. But the probable primes, there are Glerp units, include 49,000 digits, 86,000 digits, 100,000 digits, and 270,000 digits. No others below 2 million digits. I don't actually use NVIDIA CUDA, but if you play computer games like Unreal Tournament 3, you have that graphics card. It works 6 times faster with NVIDIA CUDA. And I don't have time to show the videos, but this presentation will be online, and the videos are about the NVIDIA CUDA graphics card. One of them is just amazing. The computer recognizes the faces of everybody in the hallway that's walking by. With another NVIDIA CUDA computer, it actually recognizes the mosquitoes and shoots them down with a laser. And that's done in poor areas where they don't believe in pesticides to kill mosquitoes. That's with NVIDIA CUDA. And I've discovered since February 4 more probable primes. I sieved in new PGen 210 to the power of n plus 199 after a couple days. I ran it through OpenPFGW. That's based on a Discover magazine formula. And also another theme that I was thinking about was a 10K equation, because there was the 10K web design project. It was a contest where you make the best website that you can in 10K or 10 kilobytes. So that would be 10,240 bytes. So I found the largest prime number with 10,240 digits. And another thing that I was thinking about was with the Windows calculator. Okay, this is different than the one I have at home, but okay. If you take 2 to the power of 144,269, they changed it. I guess that the one with Windows XP is different than the one with Windows 7. But
you can try to use the Wolfram.
Well,
Yeah.
Anyways, let's go back. So with the Windows XP version, if you try 2 to the power of 144,269, you get a 43,000 digit number. If you try 1 more in the exponent, 144,207, you get an error. So I set a new PGen for days, the 43,000 digit equations, and then I switched to OpenPFGW, and he discovered about every 2 days a prime number that's probable with 43,000 digits. And so I'll show you how to submit these. If you type in probable primes, search probable primes space Lifchitz, Lifchitz, and then hit enter. You get the website. Then you click on submit your PRPs. So you enter the verification code, the CAPTCHA, that's to show that you're not a machine. You choose your name if you've already submitted. And these are the 4 equations that I've just discovered since February that I just talked to you about. And you use your email address for confirmation. So I just submit it. Well, I don't know what the problem is, but it will appear on the web page in a couple days. Just submit a prime, a probable prime, and it will show up in a couple days. So there are 5 that are discovered with 1 million or more digits. I'm almost finished. I thought that I'd get the question, what's the largest candidate prime number you've tested? I have tested numbers with over 2 million digits, and the largest probable prime I've discovered has 43,000. However, reputed team member Danilo in Germany has tried to test a mole number of digits of 2 to the 2 septillion. That's Avogadro's number of digits. Yes, no factors of less than 2 to the 120th in factor 5. That is a 64-bit program, and I don't have 64-bit Windows. And I've shown you OpenPFGW, but that's the Windows version. I don't know how it's different in Linux or Macintosh. And does anybody have any questions?
So a lot of these formulas are 2 raised to some power, and then you do other stuff. Why is it usually 2 as the base instead of 3 or some other number?
Because 2, you get to find factors faster. I mean, you get to eliminate factors faster. It runs, I think it's called the Lucas-Lamer test, which I don't fully understand. You're talking about the Mersenne primes, and there are almost 50 of them. Questions?
So in terms of speed, so what if you did do like an extension at 3 to some power? Like, how would that affect the speed of determination?
Well, you'd have to use new pgen to set out the numbers. And first of all, if you have 3 to a power, and then you subtract 1, it's going to be even. So you have to have a coefficient in front of it. And it's like you have an option to use a base of 3 and use wherever exponent you want. But if there's an odd base, and then you add 1 or you subtract 1, then the coefficient has to be even. And I've gotten the question, are some Mersenne numbers more difficult to test than others? If a Mersenne prime or a prime candidate has x times as many digits, then it takes x squared times as long to prove. With 3 times as many digits, it would take 9 times as long to prove, 4 would make 16, and so on. How many primes and perfect numbers with more than 1 million digits are there? 76 for now. There are 11 Mersenne, 51 prime non-Mersenne, 5 probable primes and 9 perfect numbers with 1 million or more digits. Perfect numbers are not prime. Perfect numbers like 6 or 28. It adds up to its digits, so, I mean, it adds up to its factors. The factors of 6 are 1, 2, and 3, and that add up to 6.
Not itself.
What?
Not itself.
Right, that's right.
Factors 6.
How many primes are in Chris Caldwell's and the Lifshitz Brothers database? Chris Caldwell has over 106,000 and the Lifshitz database has over 94,000. And as far as books, I recommend The Little Book of Big Primes from about 1991, The Little Book of Bigger Primes from about 2004, and Prime Curios from your library alone. Haven't been able to get Prime Curios yet, but I think that you can get both the Little Book of Big Primes and the Little Book of Bigger Primes from Purdue. And write down my email. It's stathmk@yahoo.com if you're interested in finding prime numbers with 10,000 or more digits. And contact me first. If I don't know, then I'll contact Prime Forum, PFGW, Prime Grid, and the Mercine formula. Briefly email me if you find a top 5,000 prime or a probable prime with 10,000 more digits. This will be on PowerPoint. This will be on YouTube in April with a link to the PowerPoint. Any more questions?
So you have some prime formulas like the Euler formula, x squared plus x plus 41. Is it known whether that formula can produce infinitely many primes?
I did not think about that.
Different intervals.
No, I don't think that is known.
And somebody proved that there are infinitely many arithmetic progressions. I thought I heard that there are infinitely many twin primes.
No, that's not true either.
And
That's open problem.
Yeah.
Twin primes.
And if this doesn't, if the gigantic primes are too much for you, then try a bi-twin. Then try looking for bi-twin primes. Bi-twins are like 30 and 60, because you double it, you get 60. 29, 31, 59, and 61 are prime. So I recommend the Rep Unit project to participate in. So they have not discovered, apparently not discovered more than 50 bi-twins sets. That would be where you double it and the one that's below it and the one right above it are prime. And I have a website, mattstath.com. That's Matt, STATH.com, and then you click on top primes, and if anybody figures out a theme for primes or a group, or they have a good idea for a top 50 list, it's mattstath.com. And is there anything else?
What's your favorite prime?
What is my favorite prime? It might be Jenny's number because of the song 8675309.
Jack. It's not what number?
It's Tommy Two-Tone. he sings that song, or he meets a girl, and her phone number is 8675309. That's a prime number.
867. Area code 867.
8675309. And I think we're done.
Any more questions? Thank you for speaking to us.
Thank you.